Okay, we're going to continue on with our trig limits. So up here it says to find trig limits first, try substitution. You always try substitution first. When substitution fails, try rewriting the given limit in terms of known limits using appropriate algebra and trigonometry. Please note the following is false, and if used will result in the loss of all points. The following is false. Sine mx equals m sine x. That is just completely wrong. Consider this. Students do it all the time, but consider this. Sine of 3 pi over 2. That is -1. But if you could factor things out, not what you would get if you can quote-unquote factor things out, that a lot of students think you should be able to do that. Take that 3/2 right on out of there. And then that would be 3/2 times 0, which is 0. Clearly both answers can't be right. This is just horribly, horribly wrong. And if I see that idea of factoring out, and I hate to even say the word factor, because it's not factoring, of taking coefficients out of arguments, out of angles, you will just lose all the points. The equivalent statement for the other trig functions is also false. You may not factor out a constant from the argument of a trig function. The arguments of trig functions will not change when only algebra and calculus is used. The arguments of trig functions will only change when appropriate identities like half angle and double angles identities are used. So when you're doing your work, if suddenly you had an angle of 3x, 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 and then your angle is suddenly x, you have made a mistake. Your angles arguments are not going to change unless you did legal trigonometry, like half angle and double angle identities, those sort of things. Okay, so this guy, we try substitution first. And substitution is going to fail, but you always think substitution first. And we get 0 over 0, indeterminate. That's not how you spell indeterminate. Indeterminate. And that still may not be how you do it, but close enough. So I've got to rewrite it somehow, so it involves rewrite using algebra in this case. So that the limit as x goes to 0 of sine 3x over 3x is involved. Because I know what that limit is. I have that limit memorized. That's 1. So if I can do some rewriting so that's involved, I'll be good. So, I would like to have a 3x down here. I would like this to be I'd like that to be 3x. So I'll make it 3x. But I can't really change the value of the problem, but I can change what it looks like as long as I keep the value the same. Well, I just put a 3 in the denominator, put a 3 in the numerator. 3 in denominator, 3 in numerator. And so while the problem looks different, it has the exact same value. Then I can use my limit rules, which says that I can split limits up by multiplication. So I can view that as two separate limits. And now I've got it. That first limit, that's wrong. That first limit we have memorized to be 1. You will have that memorized as 1. The next limit, the limit of a constant is the constant, so the limit as x goes to 0 of 3 is 3. And this whole answer then turns out to be 3. So there's our first one. Doing a similar thing on the next one. Now, first of all, those coefficients in a limit certainly can factor out. So I will do that. And then I'm going to do the same thing of try to rewrite involving the limit as x goes to 0 of sine 5x over 5x. And to do that, I'm going to want this to be 5x down there. That when that argument and that denominator match, or if it was inverted, numerator and argument match, I know that limit. So I want that to be 5x. So I do whatever I need to do to get it to be 5x, as long as I compensate for it. So I'd like a 5 there. Well, I just put a 5 in the denominator. I better put a 5 in the numerator. I have x to the 1/3. I need to get that x to the 1/3 up to x. I have x to the 1/3. I need to get x to the first. Well, to go 1/3 to first, I'm going to need to put in 2/3. Well, I just put a 2/3 in the denominator. I better put a 2/3 in the numerator. Whatever you put in the denominator, be sure you compensate in the numerator, or vice versa. If you put something in the numerator, compensate in the denominator. And so what I've got here then is 7/2, limit as x goes to 0, sine 5x over 5x times 5x to the 2/3. Then technically, I can split this on up. So I have the limit as x goes to 0 of sine 5x over 5x times the limit as x goes to 0 of 5x to the 2/3. And so I get 7/2 times 1. You're going to memorize that that limit has a value of 1. That is 1. Memorize it. So I have the 5/2, or the 7/2, excuse me, the 1, and the last limit I can do by substitution. So 5 times 0 to the 2/3, and all of that is going to be 0. So that limit is 0. And we'll end that video.